Hello, everybody. Today we will be talking about half-life. Okay, we're talking about half-life. There are three orders. Okay, order number one, 0. Order number two, first. Order number three, second. And let's talk about the half-life. The symbol basically it works the same. Half-life for the first order, that is what we normally know, is natural log over k. It can also be rewritten as 0.693. And the reason for that is natural log is equal to 0.693. Okay. And for zero order, it relates to half-life is equal to initial concentration divided by 2k. For second order, half-life is equal to 1 over k times initial concentration. So initial concentration, this is the initial concentration. And k is the rate constant. T half is half-life. Now let's talk about for high school, right? You will only be dealing with this equation. You will only be dealing with this equation. This is first order is all about radioactive decay. Okay. For first order, zero order, no, first order, zero order, and second order combined, they can, when you are talking about the rate of chemical reaction. Manly solution. Okay, Manly solution. But when you are talking about half-life, mainly we are talking about radioactive decay. Now, they are on three equations that is important in radioactive decay. So equation one, A of t equal A of 0 times exponential to the power of minus kt. Okay, at is the amount of the substance amount of the substance at time t. A naught amount of the substance at time 0. Exponential basically is the constant 2.718 and so on. K rate constant. T basically is time in second, minute, hour, or year. Okay. The second equation is A of t equal A of 0 times 1 over 2 to the power of t over t half. The third equation is t half, which is half-life, equal natural log over k over k. So we can extend one more. T half is half life. Okay, half life. So now, if you combine these two, you get equation number 2. You get equation number 2. You can split 1 and 3, or you can just use 2. Okay, it's up to you. Yeah. Now, why is half life important? Because, for example, we are using, let's talk about, we need to understand, like, when we are talking about half-life, we are talking about radioactivity. Okay, and that means that you are talking about unstable isotope. Okay, that means that number of neutrons and number of protons, they are not balanced. Typically, there will be more neutron number compared to proton number. Okay, and let's talk about this uranium 92, and then atomic mass is 238. And then you can see here the neutron and proton and electron. Proton is 92, electron is 92, and then neutron is 238 minus 90, that is 148. So you can see there's an imbalance, right? So that makes it radioactive. Radioactive means unstable. And because of this instability, it would undergo radioactive decay to get to be 90 over 234. All right. And then you would it will release gamma ray. Alpha ray. Sorry, alpha ray. Or you can rewrite as helium. Okay. Basically, this is energy release. And this energy release, we can use it as nuclear power. So if you know there's a Fukushima nuclear plant that has explosion because of tsunami in 2011 in Japan. Okay, and the half-life for this radioactive decay for is 4.5 billion years. So it will take, what this means, this T half is, it will take uranium 92, 38, and 4.5 billion years to lose half of its mass to become pH 234. Okay, by mass, by mass, mass. All right, so and last thing, the reason why half-life is important. Reason? Because radioactive decay involves energy release. In chemotherapy, this radioactive um, chemical element can be used to kill cancer cell. Okay. Oh, secondly, the medical drug, for example, paracetamol. When we take in paracetamol, the half-life will help us understand how long paracetamol will stay inside our body when we take it. All right, when we take one paracetamol, how long it would be inside our body before everything um, disappear from our body system. And the third one, of course, nuclear power. All right. That is pretty much everything about half-life of radioactivity, and I hope you find it useful. Bye for now.